You know, we're constantly hearing about AI models getting bigger and bigger and bigger with hundreds of billions of parameters. But what if the real secret to unlocking AI's future isn't about getting bigger at all, but about getting smaller and smarter? Today, we're diving into this really cool process called model distillation.
All right, so here's our game plan. First, we're going to tackle the big issue with these giant AI models. Then, we'll introduce our two main characters, a teacher AI and a student AI. We'll see exactly how the knowledge gets passed down, look at some amazing real-world examples, and then wrap it all up with why this less is more idea is such a huge deal.
Okay, let's jump right in. Section 1. The giant AI problem. We've all been led to believe that bigger AI means better AI. But as we're about to see, that's really only half the story. Sometimes bigger is, well, it's just not better.
So let's just ask the big question right up front. These massive, super powerful AI models are incredible for sure, but can you actually use them in the real world? Like for the apps on your phone or the tools you use for work every single day? Okay, to really get a handle on this, look at this number, 350 gigabytes. Now, think about your laptop. A really nice, brand new one might have 16, maybe 32 gigs of memory. This one AI model needs more than 10 times that amount just to turn on. We're not even talking about training it, just running it. That is a staggering amount of expensive, power-sucking hardware.
So what this all means is that we hit a massive brick wall. Yeah, these giant models are powerful, but they're often way too slow for a real-time chat, they're way too expensive for most companies to even think about running, and they're just physically too big to fit on your phone. It makes them completely impractical for so many things. So if being huge is the problem, then what's the solution? Well, this brings us to Section 2 and a really clever idea called knowledge distillation. Honestly, the best way to think about it is like setting up a mentorship between two AIs, a wise old expert and a quick, eager student. The basic idea, which was first floated by AI pioneer Geoffrey Hinton, is actually pretty simple. You take a massive, incredibly powerful model, we'll call that one the teacher, and you use it to train a much smaller and more efficient model, the student. The whole goal is to pass on all that deep knowledge, but without all the bulk. And this little chart just nails the whole dynamic, right? The teacher model is this giant, resource-hogging machine that knows a ton about everything, but it's kind of slow. The whole point is to create a student that's small, super fast, focused on a specific job, but has soaked up all the core wisdom and thinking skills from its giant mentor.
But how does this teaching process actually work? It's way more sophisticated than just having the student copy the teacher's answers. No. The real secret sauce is in teaching the student how the teacher arrives at those answers in the first place. This is it. This is the magic right here. It's not about copying the final result. It's about transferring the teacher's entire reasoning process. The student learns to see the subtle patterns, the logic, the intermediate steps. It literally learns how to think, not just what to say.
A really popular way to do this is called distilling step by step. Think of it like a math teacher who doesn't just give you the final answer. Instead, they show all their work on the board explaining every single step they took to solve the problem. The student model is then trained to mimic that entire chain of thought, not just the answer at the end. It's learning the why, and that's what makes it so smart.
Okay, so this all sounds great in theory, but does it actually work out there in the real world? Oh, absolutely. Let's look at some rockstar examples of distillation in the wild that have created some of the most powerful, efficient AI we have today. A classic case is DistillBERT. Its teacher, BERT, is a super smart model from Google, but it's kind of slow. Through distillation, its student, DistillBERT, came out 40% smaller and a whopping 60% faster, while keeping 97% of its teacher's brain power. I mean, for an app on your phone, that speed is everything. It's a total game changer.
And get this technique is also leveling the playing field. A small team at Stanford created the alpaca model. They trained it for less than $600, and it performed almost as well as OpenAI's gigantic GPT 3.5. This sent a shockwave through the open source community, proving you don't need a billion-dollar budget to build something amazing. And here is where things get absolutely wild. In some experiments, researchers found that a student model with less than 1 billion parameters didn't just get close to its teacher, it actually beat its massive teacher on key reasoning tests. Just let that sink in for a second. The student model, which was more than 700 times smaller, actually became smarter than its mentor. It's incredible. It suggests the big models might actually be a little bloated, and distillation helps the student focus on what really counts.
Okay, so we've seen the how.
we've seen the proof, but let's bring it all home. What does all of this actually mean for us, for the tech we use every day? This brings us to our final section, the real-world payoff.
The benefits here are huge. First off, costs go way down because you don't need a data center's worth of hardware. That means apps can be faster, way more responsive. It also means powerful AI can finally run on your phone or laptop, not in the cloud. And when it runs on your device, your data stays on your device. That is a massive win for privacy. It's a chain reaction. Smaller means cheaper, faster, and more private AI for all of us.
At the end of the day, distillation is what makes AI practical. It's the bridge that's taking these incredible technologies out of the giant tech company data centers and putting them on the edge, putting them in our cars, our phones, and the tools that doctors and scientists use every single day.
And so this leaves us with a really fascinating thought to chew on. As we watch AI evolve at this incredible pace, maybe the big race isn't about who can build the biggest model anymore. Maybe the real revolution is all about who can make AI smaller, more efficient, and ultimately, smarter than ever before.